Hello, dear students. In the last class or in the classes we had taken earlier, we had discussed about water tube boilers, fire tube boilers, packaged boilers, then stoker fired boilers, chain grate or traveling grate stoker boiler, etc. Now we move on to spreader stoker boiler. Please see the figure. This is a combination of suspension burning and grate burning. Coal is continuously fed into the furnace above a burning bed of coal. You can see the figure. There is a coal hopper and a feeder and a spreader, and through the spreader the coal is spread over the bed in which the coal is falling onto a burning bed of coal, and the larger particles will be falling onto the bed and the smaller particles will be getting ignited before falling into the grate, or the smaller particles will be getting ignited while in suspension. This method of firing provides good flexibility to meet the load fluctuations, since ignition is almost instantaneous when the firing rate is increased. The next is pulverized fuel boiler. And this is used in mainly in coal-fired power stations. And in this, over the 90% of the coal-fired boilers are pulverized, having pulverized fuel boilers. And before giving to the burning position, the coal is pulverized, and the pulverized coal size is 75 microns for nearly 70 to 75% of the fuel, and for less than 2% it is plus 300 micrometer. And this pulverized coal is given to the combustion chamber through a series of burner nozzles, or in other words, there will be 2 or 3 or more type of nozzles depending upon the combustion chamber, and if necessary, secondary or tertiary air is added. And the combustion temperature is comparatively high of 1300 to 1700 degree centigrade. And since the pulverized coal is given, the fuel particles will be suspending for a very short duration of 2 to 5 seconds before getting ignited. And another thing which is obvious is that the particles should be small enough so that this fuel should be able to be blown through the burner nozzles. And the advantage of pulverized fuel boiler is that it has the ability to fire varying quality of coal, because coal sourced from various locations have different quality and different gross calorific value. So this type of boilers will be able to handle different type of coal, and it can also respond to quick load change, and also high preheat temperature can be used. And since the method of firing includes the usage of burners and nozzles, the popular method of firing is a tangential method, which we'll be discussing. Please see the figure, and this is the method of tangential firing. You can see the primary air and fuel is given, and secondary air is also given, and air is given so that there is sufficient air coming inside the combustion chamber so that the fuel is burned in minimum time, and all the fuel is burned perfectly without lossage of fuel. And the tangential firing method is utilized with this type of nozzle arrangement. Next is the fluidized bed combustion boiler known as the FBC boiler, and please see this figure. And the water is given as inlet, you can see, and steam is going up as indicated in the arrow. Coal is given from the left side as shown in the figure, and combustion gases will be moving out to the chimney after combustion, and it is shown on the right side as combustion gases. In this, a floating heated sand is made, or you can see the air marking here, and this part is having heated sand which is blown up with the help of air, and the heated sand will be standing in suspension, and the heat will be equal to the igniting temperature of the coal, and coal is given. When the coal is given, which is reaching this combustion chamber, which is standing at the ignition temperature of the coal will be getting ignited immediately, giving a heat transfer to the water tubes, which will generate steam as shown here. And the advantages, and before that, the ash collection can be dry or wet type, because you need to transfer the burned fuel in the form of ash, and it should be removed immediately so that fresh coal can be given continuously. And the advantages of fluidized bed combustion boiler is having fuel flexibility, and again it have reduced SOx and NOx emissions. SOx stands for oxides of sulfur, and NOx stands for oxides of nitrogen, and these emissions are very less. That means it is comparatively environmentally friendly, giving less harmful emissions to the environment, and has high combustion efficiency, and also it is a very compact boiler design. Next is performance evaluation of boilers, and there are a number of parameters, but the major performance parameters are efficiency and evaporation ratio. And regarding boiler efficiency, it is defined as the percentage of heat input that is effectively utilized to generate steam. In other words, percentage of heat input means the heat content of the fuel, and there are two methods, which is the direct method and the indirect method. And in the direct method, energy gain of working fluid, it is either water or steam, is compared with energy content of the fluid. Or in this energy content, there will be, if it is furnace oil or if it is coal or anything, the fuel which we are giving have an energy content. It is expressed in kilocalorie or in megajoule, and it is compared, the heat, the energy content of the fuel is utilized to generate steam, and this is compared with the energy content of the fluid. It is a direct method. And the indirect method, it is simple as that the energy input minus losses. That means we know the energy input, and if we know the losses, energy input minus losses is the indirect method. And now we move on to direct method. This is known as the input output method, and it notes only the useful output steam and the heat input of the fuel for evaluating the efficiency. Or boiler efficiency, simply in other words, just like in any efficiency calculation, this heat output by heat input. The advantages of direct method is quick evaluation of the efficiency of the boilers, and it requires only a few parameters for its computation, and you need only few instruments for monitoring. And the disadvantage is that it does not give clues to the operator as to why efficiency of the system is lower, because we need to use other methods or instrumentation to find out why the efficiency is lower if you are getting a lower efficiency while calculating using direct method, and does not calculate various losses accountable for various efficiency levels. And again, we are moving still on the direct method, and for finding the efficiency using direct method, we need to know the following parameters. and it is one is quantity of steam generated per hour. It is denoted by Q in kilogram per hour. Then quantity of fuel used per hour, small q, in kilogram per hour. The working pressure in kilogram per centimeter square gram, and superheat temperature degree centigrade if any. Then the temperature of the feed water and type of fuel and gross calorific value of the fuel in kilocalorie per kilogram of the fuel. And this is a constant for a particular type of fuel. And the direct method, by using the direct method, the boiler efficiency is given by Q into Hg minus Hf by G into GCB into 100, where Hg is the enthalpy of saturated steam in kilocalorie per kilogram of steam, and Hf is the enthalpy of feed water in kilocalorie per kilogram of water. This is the simple method, and we'll be also seeing an example how efficiency is calculated by the direct method. It is so simple actually. There is no only direct substitution. And an example is type of boiler is coal fired. Quantity of steam generated is 8 tons per hour. Steam pressure gauge temperature is 10 kilogram per centimeter square gram at 180 degrees centigrade. Quantity of coal used is 1.8 TPH. Feed water temperature is 85 degrees centigrade. Gross calorific value of coal is 3200 kilocalorie per kilogram. Please note that this will be varying depending upon the type of fuel used and type of coal used also. And enthalpy of steam at 10 kilogram per centimeter square pressure, it is 665 kilocalorie per kilogram, and enthalpy of feed water is 85 kilocalorie per kilogram. And by finding out, there is only direct substitution, and boiler efficiency is now calculated as all the above data is 8 into 665 minus 85 by 1.8 into 3200 into 100 is given as 80%. Or in other words, the boiler efficiency is 80%, 20% is lost as another losses, and how that can be found out is a different area of study.